For any medical device, the FDA establishes standards and regulations to assure safety for the population and consistency throughout manufacturers. Cochlear implants are no different. For cochlear implants, the FDA recommends 5 different fields that must be tested: output amplitude, immunity to MRI testing, effective tensile forces, effective direct impact, and effective atmospheric pressure. A lot of these tests are actually involved on the probe itself and on the array. Here you can see a sample array where one channel is led to only one electrode, as we've talked before. First, we'll talk about output amplitude. Why is this important? Because you want your desired output to be what you expect. If there's a miscalibration, you could either be recreating improper sounds or even harming a patient. So this is very important. The FDA establishes a deviation of plus and minus 5% of the maximum amplitude and pulse width. So when there's set to the maximum, it can only have a deviation of 5% from that point. The way it tests this is by inputting a 70 decibel noise into the microphone of the cochlear implant, which is very loud. It's a very powerful sound. You would be in a lot of pain if you were hearing this. The microphone then does its filtering to the different channels. Each of these channels has a 1000 ohm resistor that is being monitored by oscilloscopes. With this oscilloscope, we can track both the amplitude and the pitch of and the pulse width of these devices. And if they're within specification, great, then that means they pass the test. Another very big factor that needs to be tested is the fact that these implants are within your skull. And if you ever need to have an MRI, you need to be sure that no problem will occur because there's electrical components. MRI has a magnetic field. This is a very dangerous situation in a lot of situations. So the FDA requires cochlear implants to be immune to the MRI. So how is this accomplished? So the test works in such a way that there are 2 saline-filled plastic boxes and the cochlear implant. They're first put into the room where the MRI is so that they acclimate to the temperature. After they've been there for 24 hours, one of these boxes is opened, the cochlear implant is put inside, and then these 2 boxes are put in the center of the MRI. Once this is done, the MRI is turned at full power for 15 minutes, trying its best to recreate the worst case scenario for this cochlear implant. Once this worst case scenario happens, the cochlear implant is removed and tested. If it's performing as intended and as it did before, then it passes. If not, it fails. There's only one single clause to this case where manufacturers can allow for some discharging of the battery, but that is a very minor exception. Here you can see the diagram of how the process works. Another very large testing standard is tensile forces. The reason why this is important is because these implants are normally put in children. Children grow, that means the distance is stretched, and these implants need to be able to accommodate to that. So to test this, there's 2 different specimens. Specimen A is just a commercial implant, nothing different, and then specimen B is a commercial implant without a stimulator. So for the testing itself, both of the leads of each of the 2 specimens are elongated with a force of 1 Newton or 15 millimeters of stretch for at least 1 minute. Once this is done, specimen A is submerged in saline solution, and specimen B has a 1 kilohertz square wave with an amplitude 2 times its max voltage. This is to test both of the extreme situations that might be happening within the spectrum of possibilities. Once the stress testing occurs, specimen A must have electrical continuity, and specimen B must have an impedance in between its 2 pairs, in between its 2 leads of over 100,000 ohms. So if this passes, then great. If not, technical redesigns are necessary. Then we get to the most common ones, which are just direct impact or atmospheric pressure. People fly on planes, people go scuba diving. It's essential that these devices can handle changes in atmospheric pressure. So the testing for this is done by taking it from ambient pressure, which is just or surface area, surface level, to 1.5 times the maximum pressure allowed in this by the manufacturer. So, and this is done 20 times. So it goes from 0 to 100 to 0 to 100 to 0 to 120 times. And if the device is able to function normally after that, it's deemed as safe for atmospheric changes. So you can go scuba diving, you can go on a plane, anything you want. Meanwhile, the direct impact, the way this is tested is by two different hammer strikes. One of them is done perpendicularly with a force of 1.5 joules plus minus 5%. And this is when the device is held down and just hit square in the middle. And then another one with the same force at its weakest point in an off-center strike. So this is, again, to check. I mean, you might fall down, hit your head. You want to make sure that this device can handle at least some rough and tumble, because these devices are supposed to improve quality of life, not worsen it.